Presentation.
My name is Eduardo. I'm a physicist. I studied my bachelor in Mexico. I'm from Mexico. And I also did a master's degree in Mexico. And then I went to Gothenburg to work on a master project. And then I arrived to Denmark to work on a PhD project for 1 year. And this project is called, it's a very new research that is called nonlinear quantum optics, in which what we want to do essentially is to study the nonlinear effects at the level of single photons. We just need a highly nonlinear media that in this case we use ultra cold atomic cloud. By using lasers, we can decrease the temperature of an atomic cloud to the level of 10 microkelvins, and then with that we can make the atoms be just almost frozen in space. Developing a better scheme of quantum information processing, or we can also do optical transistors or quantum memories. The transistors, they work with electrons, and electrons has a lot of dissipation, and they release a lot of heat, and they have this limitation of speed also. But with an optical transistor, that would be a transistor that works with photon interactions, and the amount of dissipation is much lesser than with electronical transistors. So it will be then more faster and more efficient.
Your research work.
Well, I characterized the population of these lights, and another thing was this synchronization of the camera. Another thing that I did was that I characterized a high voltage electric field. In this project, we merged two things. The first one is called EIT, and the second one is called Rydberg atom. So I just sketched here like a very simple atomic scheme of 3 levels, and then what I want to show is that if we have 2 optical fields, one it's coupling the ground state to an intermediate state with this coupling coefficient. If you have the right conditions and you couple one common state, then once again with right conditions you can have this state be transparent to this optical field, so that if you shine this radiation to this system, then this is going to be transparent. It's not going to be absorbed. It's not going to be scattered. So then you only have like an effective coupling. Like if you will just skip this and just go right to the excited state, and this is called EIT. This is EIT, which is electromagnetically induced transparency, because you induce the transparency in this level, and this is the quantum mechanical effect. So you get you change the 3-level susceptibility to 2-level susceptibility.
Rydberg atoms.
The Rydberg atom is so susceptible to external fields, because the electron it's excited to a highly quantum number state, and it's almost loose from the atom. So with a very decent electric field, you can just detach the electron from the atom, and then you can have this ion that you can just guide it to some microchannel plate to detect that you have the Rydberg atom before. So That's why I work with this high voltage electric box in order to ionize the Rydberg atoms and to guide them to the detector, so we can be sure that we have Rydberg atoms first, and then to further control of our quantum states. And the interesting thing is that they interact strongly with the atomic neighbors. If you send two photons, yeah. So send two photons, and then once it's absorbed by one of these atoms, and then it creates this what we called the Rydberg blockade, which is the thing that I explained, that it shifts the energy levels of the neighbor atoms. When it creates this Rydberg blockade and it shifts the levels, the EIT breaks down. The conditions for this induced transparency breaks for the second photon. And then the second photon, it just scatters and it gets lost. So the media behaves differently for one photon than for two photons. And that is a very strong nonlinear optical effect.
Future plans.
Okay, my future plans is to study a PhD in a group whose research is of positive ions. Like they have two storage rings, one for positive ions and one for negative ions, and then somewhere in the middle these rings cross together, and you can study the interaction of these ions